Most of these easy ideas we have about time are wrong.
Det handler om alt fra sorte huller og LSD, og til hvorfor tiden går langsomt under en corona-lockdown, men hurtigt, når du er presset.
The way we memorize things affect the way we think about time.
Når vi fortæller historien om, hvordan tid, som du kender det, i virkeligheden ikke eksisterer.
The way we usually think about time is wrong. In some sense, there's no time at all. Time doesn't exist.
Men faktisk begynder den her historie allerede for 100 år siden med den danske forsker Niels Bohr. For det er hans idé om, hvordan de allermindste ting i universet opfører sig, som er grundstenen i, hvad tid er.
He understood how profoundly we have to change our view of reality if we want to understand the world. When I started studying all this, I was like a rebellious young man with very long hair, all the way down here, and very passionate about everything I was doing. I was experiencing with drugs at the time, with psychedelic drugs, and it was strong. It was intense. It had a lasting effect on me. It helped me to question reality as we usually see it. I remember, for instance, some things happening in my head and the sense that hours and hours have passed. Then looking at the clock, and the clock says it's just 2 or 3 minutes, and thinking, oh my God, what happened? I mean, my sense of passing time is completely changed. It tells us that the way we perceive time is in our head.
For at forstå, hvordan vores opfattelse af tid kan svinge så meget, og hvad det betyder, er vi nødt til først at forstå, hvordan vi som mennesker egentlig opfatter tid. Og det fortælles lettest ved brug af musik.
Just marvelous. Time for us has a span which is related to our memory and expectation. And he noticed that, think about music. When you hear music, in each moment you're hearing one note. So where's the melody? It's in our memory, it's in our mind. It's a memory of what you heard before, and then we expect what comes next. So the music is in the part of our brain that remember the past and anticipate the future. And in a sense, this connection between memory, anticipating emotions, it's at the core of what is time for us. It's a time that our brain constructs.
Tiden er for os altså en linje, som syes sammen af oplevelser, der lige har været, og så forventninger. Vi husker fortiden og forventer fremtiden, og har derfor en følelse af tiden.
So we remember the past, we anticipate the future, but this is a dramatic thing for us. Because the past is what we lose also, and the future is what we want and what we fear. Because we're going to die, because we're going to lose the people we love, because we want something in the future. Time is something deeply connected to our emotions.
At vores følelser spiller ind på vores tidsopfattelse, er også det, der gør, at du kan opfatte tid så forskelligt, alt efter hvad der sker i dit liv. Det er derfor, at en periode med corona-lockdown kan føles som om den kører i sit helt eget langsomme tempo. Og på samme måde så oplever folk i følelsesmæssigt pressede situationer, som for eksempel et biluheld, at tiden i ulykkesøjeblikket går i slow motion, fordi der er så mange indtryk på kort tid.
And I think this underscores clearly the fact that the time of our experience is not the same as the time of our clocks.
Vores egen indre tid er altså elastisk og på ingen måde den samme som vores ydre tid, altså den tid, der styres af ugerne. Men som det vil vise sig nu, er den tid faktisk også elastisk. Vi skal en tur downtown Verona.
This is my hometown. I was born here, and we are in Piazza Erbe, which is the center, the old Roman center of the city. This is the Torre dei Lamberti, where this big clock is there. It's a main reference point in Verona. Well, humankind has found this way to make time into very concrete things by inventing clocks. We have agreed to all connect to these machines that define time.
Men den her ydre fællestid, som styres af mekanik og ure, den er altså også elastisk. Lad os som eksempel tage de 2 ure, som Carlo Rovelli står og ser på midt i Verona, tårnuret og hans armbåndsur.
Up there, there's more time than down here. It's due to the presence of the Earth. So one thing we have discovered is a fact of nature. When there's a big mass, the Earth is a big mass, time slows down. The difference between the time of my clock and the time of the big clock up there, it's real, but it's very small. So since it's very small, we don't care. Who cares about a millisecond every 20 years? But science is works on details, because details reveal what's wrong in some idea. So these small details tell us that time is not what we think it is.
Nej, tid er ikke, hvad vi tror. Den påvirkes altså af masse. Og det er jo ikke bare jorden, der har masse. Alt har masse. Et menneske har masse. En vanddråbe har masse. Selv de mindste ting i universet har masse. På hverdagsdansk vil vi sige, at tiden påvirkes af alt, der vejer noget. Og da jorden er den ting, som er tættest på os med mest masse, så betyder afstanden til den mest for os.
If you go to live in the mountain, and then you come down, you have lived longer than your friends who remained by the sea.
Det er dog stadig tidsændringer i meget lille skala, men hvis vi tog en tur ud i universet til et sort hul, så vil der virkelig ske noget med tid. Et sort hul opstår, når en stjerne imploderer. Det er en slags omvendt eksplosion, hvor hele stjernen trækkes sammen og fylder meget lidt, men stadig vejer det samme. Med tiden kan et sort hul komme til at veje billioner gange mere end jorden.
If you were very near a black hole, time doesn't pass there, almost nothing. So you can go very close to a black hole, wait a few minutes there, come out, and centuries have passed. What happens is that when there's a mass, time slows down near the mass. So because of that, the passage of time is different in every location. So you cannot really say that in the universe so much time has passed, because somewhere has passed, somewhere hasn't.
På den store skala er tid altså ikke den samme nogen steder. Men det hele bliver faktisk endnu mærkeligere, hvis vi dykker ned på den helt lille skala.
You lose time as we usually think about it when you go at very small scale. If you look at inside the atoms, in the protons, inside the nuclei, inside the quarks, smaller and smaller and smaller. So because when you go very small, the quantum gravity effect become important.
Det her med kvantegravitation, det kræver nok lige en forklaring. Og det kræver så igen, at vi hopper cirka 100 år tilbage i tiden. Dengang opdagede den danske forsker Niels Bohr en ting, som senere ville blive en del af en af verdens største teorier, kvantemekanikken. Alt i verden består af atomer. For eksempel består et menneske af milliarder og atter milliarder af atomer. Og inde i hvert eneste atom er der en kerne, og omkring den svæver en eller flere elektroner. Og det, som Bohr fandt ud af, var, at de elektroner kun kan være i nogle helt bestemte afstande fra kernen. Hvis vi skal prøve at oversætte det til hverdag, så forestil dig en vanddråbe. I stedet for, at den kan bevæge sig i en flydende bevægelse, så kan den kun indtage helt bestemte positioner. Ting i kvanteverdenen flyder altså ikke, og det vilde er, at det ifølge Carlo Rovelli også gælder for tid.
In the small, many physical quantities are not continuous. They can only have certain values. Now this is also true for time. This means that we can think a second, we can think half a second, a quarter of a second, a tenth of a second, smaller and smaller and smaller and smaller, but not forever. We get to a minimum time. It's very small, very teeny. It technically is 10 to the minus 44 seconds.
Men ikke nok med, at tiden bevæger sig i hak. Nej, de små dele tiden kan deles op i, behøver ikke engang at holde deres rækkefølge.
Quantum means that everything fluctuates, including what we usually call time. You cannot order events in time 0, time 1, time 2, time 3, because their order changes. So the notion of time is not good anymore.
Hvis vi ser på vanddråben igen, så er ikke nok med, at den bevæger sig i hak. Den kan gå begge veje. I de her størrelsesforhold er der altså ikke noget, der hedder fortid og fremtid. Der er ikke én retning, som er den rigtige. Men hvorfor oplever vi som mennesker så, at tiden går i én retning? Jo, det skyldes faktisk to ting. Varme og så den kendsgerning, at vi ikke kan se helt små ting.
There is something very peculiar about the direction of time. The distinction between past and future is there only when there is heat, something hot, like a cup of coffee, or when there's a difference of temperature. If you film some phenomenon, if you film the Earth going around the sun, and you present it backward, it's still reasonable. So you never see the difference between the past and the future in those kind of phenomena. But if you film a water with some ice, and then the ice melts, and then you show the movie backward, you see ice forming in cube inside water. It makes no sense. So these are phenomena that distinguish the past from the future. And every time there's a distinction past-future, there is heat. And heat and temperature are the great number of molecules moving fast. Why this is hot? Because there are many molecules moving fast. It's only when there are many little things moving that time has a direction.
Lad os lige hoppe ind i Carlo Rovellis kaffe. Varme er altså, når molekyler bevæger sig hurtigt, og med varmen har vi en retning af tiden. Men det helt mærkelige er, at hvis vi kunne se de her molekyler, som bevæger sig, så vil der faktisk ikke være en retning i tiden.
If we saw the molecules, of course, there are many possible ways in which they're moving, and if you could show a movie of the movement backward, it would seem perfectly natural, because it would look like plausible. But if you could see all the details, you would have equal knowledge of the past and the future, so for you there would be no difference. The direction of time does not exist. It only exists because we as humans have this blurred vision. We don't see the individual molecules.
Verden er uforståelig, når vi kommer ned i de allermindste størrelser. Og selvom det lyder fuldstændig mærkeligt, at tiden kun har én retning for os, fordi vi ikke kan se, hvordan molekyler bevæger sig, så er det sådan, tingene er på grund af kvantemekanikken. Den teori, som opstod med den danske fysiker Niels Bohr.
I think his deepest legacy is that he understood that how profoundly we have to change our view of reality. I don't know how quantum theory could have developed without him. The impact of Bohr has been immense.